This is a solution of the class 8 physics paper that was given for the half yearly. Which state of matter has the least intermolecular force but the maximum intermolecular distance? This is gas. Which is not the way to increase the rate of evaporation of a liquid? Increasing the pressure over the liquid will decrease the rate of evaporation. So that is not the way to increase the rate of evaporation. And if you look at the other options, you could have also looked at this one and this one. Increasing the temperature, you increase the rate of evaporation. Increasing the surface area of a liquid, you increase the rate of evaporation. For example, if you spill water from a glass on the floor, because the surface area is increased, evaporation is faster. Which of the following is not an example of vaporization? Evaporation is vaporization and so is sublimation. So the option which is correct is condensation. This is interesting. When a gas enclosed in a 20 ml container is carefully transferred into a 100 ml container, its volume becomes. So we know that gas has got neither a fixed shape nor a fixed volume. So gas molecules tend to move away and expand and fill the container. So this one is that when you transfer a gas from a 20 ml container into a 100 ml container, then the volume of the gas will become 100 ml. Evaporation causes cooling because this is the first option. Molecules with the maximum kinetic energy evaporate. So because the residual molecules have less kinetic energy, their temperature decreases. The density of wood is 0.8 grams per centimeter cube. So if you look at your notes, to convert from CGS unit into SI unit, as far as the density is concerned, we multiply by 1000. So 0.8 into 1000 will be 800 kg per meter cube. The density of mercury is 13,600 kilograms per meter cube. Its relative density is, so we know relative density is density of the substance divided by the density of water. In this case, the density of mercury is given in kilograms per meter cube. So when you divide by the density of water, that should also be expressed in kilograms per meter cube. So 13,600 divided by 1000 will give you 13.6. So this option is the correct one. Then we have the weight of a floating object. Now we know that when an object floats, the upthrust is equal to the weight. Therefore, the apparent weight will be 0. So a floating object, remember, is weightless. Therefore, the weight of a floating object is 0. Which amongst these is not a postulate of kinetic theory? All matter is made up of molecules is definitely kinetic theory postulate. Molecules move randomly is also a postulate of kinetic theory. This one, molecules attract each other, is also a postulate. Molecules generally repel each other is not a postulate. Molecules do repel each other, but that is when they are very, very close. So that is not something that is postulated in the simple theory that is given in class 8. A solid weighs 20 gf in air. When immersed in water, its weight decreases by 5 gf. So the decrease in weight is actually the upthrust. So if you just look at this once again here, when the solid is being immersed in water, its weight decreases by 5 gf. So why is there a decrease in weight? Because of the upthrust or the buoyant force. Therefore, the upthrust acting on it will actually be 5 gf. Now, which of the following examples is, which of these is an example of turning effect of force? Tying a shoelace does not involve any turning. Hammering a nail also does not involve turning. But opening a lock with a key will involve turning the key. So that is an example of turning effect of force. Torque and moment of force, are they the same thing? Yes, they are the same thing. So this option is true. Buoyancy or buoyant force is the same as apparent weight, upthrust, weight in liquid. So buoyancy or buoyant force is the same as the upthrust. If you look at this option, apparent weight and weight in liquid, they're actually the same. But buoyancy or buoyant force is the upthrust. Question number 14 says, when a 80 centimeter long spanner is used to tighten a nut with a force of 10 Newton, the torque is, so torque is F into D. So the force you are using is 10 Newton. The distance is 80. So we divide by 100 to convert it into meters. So 8 Newton meter. So this option, 8 Newton meter, is going to be the correct option. Question number 15. When a 100 Newton thrust is applied on 1 square meter of area, the pressure applied is, so pressure is thrust upon area. So this is 100 Newton thrust upon 1 meter square area. So it's going to be 100 Newton per meter square. So it's going to be this option. Like when I write it, I can write it like this. So this option is going to be the correct option for number 15. Give any 3 postulates of kinetic theory. This is something you can check from the exercise copy. Like all matter is made up of molecules. That's number 1. Molecules are in a state of continuous random motion. That could be number 2. Number 3 would be molecules attract each other with a intermolecular force. So these could be the 3 postulates. Camphor or naphthalene balls, why do they decrease in size over time? Because of sublimation. Then number 17, on the basis of kinetic theory of matter, explain why solids have definite shape and volume. That's because solids have molecules that are very close. So they vibrate about their fixed positions. So because the molecules don't leave their positions, solids have a definite shape and volume. So you could simply say that it is because of the very small intermolecular spaces and the high intermolecular forces of attraction. Melting point is a temperature. It's the constant temperature at which a solid changes into the liquid state, and melting is the process by which a solid changes into the liquid state. So melting point is a temperature and melting is a process. Now state Archimedes' principle. So Archimedes' principle is simply that when a solid is immersed in a liquid, it experiences an upthrust that is equal to the weight of the liquid it displaces. If you look at the question, it says when a solid is completely immersed in water, it weighs 100 gf. If the weight of the water displaced by it was 50 gf, what is the actual weight of the solid? So we know that the apparent weight is the actual weight minus the upthrust. So if you see here, when a solid is completely immersed in water, it weighs 100 gf. So the weight in water, which is the apparent weight, is 100. Now they asked us to find the actual weight. Now what is the upthrust? If you remember Archimedes' principle, it says the upthrust is equal to the weight of the liquid displaced. So in this case, the liquid is water. So the weight of the water displaced is 50 gf. So that is actually the upthrust. So this is 150 gf. So this was an important question, made simple by the fact that Archimedes' principle was asked. So if you knew what Archimedes' principle is, you could have easily done it, because Archimedes' principle is telling you that the upthrust is equal to the weight of the liquid displaced. So here the weight of the liquid displaced, that is weight of the water displaced, is given as 50. So that happens to be the upthrust. So all you need to do is put it in this simple equation and solve it. The density of wood is 8000 kg per meter cube. So density is, sorry, not 8000, 800 kg per meter cube. So in CGS units, it is 800 divided by 1000 grams per centimeter cube. So that is 0.8 grams per centimeter cube. So why do we divide by 1000? This was explained in the class. So if you want to remember, it is 800 kg per meter cube is 800 into 1 kg per meter cube. So this is 800 into 1 kg divided by 1 meter cube. So this is 800 into 1 kg. And what is a meter cube? It is 1 meter by 1 meter by 1 meter. So 800. Now this 1 kg is 1000 grams. And this is 100 centimeters into 100 centimeters into 100 centimeters. So that actually, this one is the reason why we divide by 1000. So 0.8 grams per centimeter cube. Of course, you don't have to do all this. If you just remember that to convert from SI to CGS, we divide by 1000, and to convert from CGS to SI, we multiply by 1000. A screw can be opened by applying a 50 Newton force on a spanner of length 0.1 meters. So if I were to just, so this is your screw and say this is your spanner. So you are applying a force of 50 Newton on a spanner of length 0.1 meters. So the torque you are generating is F into D, which is 50 into 0.1, which is 5 Newton meter. Now the question is asking what should be the length of the spanner if a boy can apply only 25 Newton force. So remember, he has to tighten or loosen the nut, for which he requires 5 Newton meter, but in his case he can generate only 25 newtons, so the spanner will have to be longer. So 5 by 25, or D is going to be 1 by 5, which is 0.2 meters. So in the case of the boy who can only apply 25 newtons, the spanner has to be longer, so double in length.